Hello everyone and welcome to this Autodesk Robot Structure Analysis video tutorial in which we are going to model industrial warehouses using steel. Now please notice that this video or the entire robot video series for the industrial warehouse is a video series that is going in tandem, in parallel with another video series where I'm going to discuss the theory of those things, which I will link right now in the top right corner. So please double check that video series first and then check out this robot series. There will be videos in the theory part and in the robot part dropping weekly. So sit back, relax, and enjoy the show. I highly recommend you check out the theory part first and then check out the robot part second. I will also have a playlist that sorts the videos between theory and modeling parts together in a more coherent way. So with that being said, let's start modeling. Now please notice that I'm referencing the steelconstruction.info. This is an encyclopedia for the UK, and in this encyclopedia the referenced code is basically the UK Euro code with the UK annex. And also I've been getting more requests lately, like to treat those bigger videos as one independent package. So I'm going to do that. So if you open Autodesk Robot this time, I will start by setting up my preferences. Now, do you have to do this every time? The answer is no, because if you have set up your preferences once, you can save it as defaults and you don't need to set the preferences again. Also, I have a video talking about the job preferences and the GUI and so on, the simplistic things about robot in the top right corner. I will reference this in the top right corner. So without further ado, let's go to job preferences. Now today I will be using the Euro code everywhere. I am an ASI guy and an American code guy, but today I will be using the Euro code. For the entire warehouse series, I will be using the Euro code because there are people who are interested in this. Please notice that the selection of the code itself will not pose a big difference. There are still some differences between codes. And well, let's dive into that. So if you go to job preferences, you can access this by clicking on the toolbox here and clicking job preferences, or going to options, or tools, sorry, and options. And in units and formats, you can just by one click select between metric and imperial, or you can just dive deep into it and basically select the dimensions you want. Structure dimensions are the dimensions of the general structure, the section dimensions, and so on. This means the number of decimal places, and this means if you want to have the scientific 10 power something. I think I like those things. You can also select the forces. You can select other things like displacements. You can even change the factors used. For example, 1 kilogram equals 9.806 newtons. In materials, I'm going to using the Euro code, so I should select materials as European compatible. Now if you select Deutsch, which is German, this is also Euro code compatible. You can see this concretes here. But there exists a Euro code material database, which is kind of cool. Notice that those are the same as the German Deutsch code. I mean, here it says Stahl, Beton, and Holz. This is basically the names of the materials in German. Of course, I'm going to take on Eurocode now because I want to use the Eurocode. I selected the Eurocode materials. Why is it important? Because if you want to design using Eurocode, you better have the Eurocode materials available for you. I mean, you are not going to design using the Eurocode with materials from the American standard, because I mean, look, if you click on American here, then you get the concretes that are based on the ASTM standard, which is compatible with the ACI and AISC. So I'm going to go back to Eurocode and continue this. Actually, Robot will warn you if you have not selected Eurocode. Going to databases, here you cannot change anything, but you can change inside. For steel and timber sections, I want it to be using the Eurocode. It's there, so everything is fine. Notice that it's not the first code. So if you try to open a section, you will not have it as the first default section database. You can easily make this default by selecting it upwards. And now, whenever you want to define a section, the Eurocode sections are the first things that will come into view. For vehicle code, I don't have any vehicle loads, so I will ignore that. However, if you want to add any codes, you can just select a plus button here, and you can select any vehicles you want. Euro. Yeah, see, this is like the traffic roads and bridges. Those would be defining the standard trucks you would be using for design of bridge structures. I'll add that, although I don't need it. You can actually click here and select it as default if you want. You go to standard loads. Now standard loads is the ASCE. I will not have the ASCE. I want to use the Eurocode. So, okay, which one of those? Eurocode 1. How do you select that, right? All of them are EC1, by the way. All of them should be EC1. And it's strange that I have so many EC1s. It's kind of annoying. I see this EC1 because it's Eurocode Part 1, 2002. Now, if you go EC031, it's Gewichtsbelastung. No, wait. Gewichtsbelastungen folgens Eurocode 1. I think this is not German, but it's maybe Dutch or something. This is basically the same as this, but for another national annex, I guess. I will just select EC001, and I'll add that, and I will select this as default. In the soil, there is only a soil database. I would be surprised if I have a Eurocode soil database. I don't think that. It's international. I don't think you will need this anyway, because you can just add your phi and c and so on. Phi being the friction angle and c being the cohesion. Okay. Bolts, it's ASTM Imperial. You can actually select ASTM Metric. You can select the DIN, DIN, Deutsche Institut für Normierung. That's German. I will be covering this in the theory part, and then I will be selecting my bolts based on that theory part. But you know what? Because I think I will forget, I will just select EN here first and just enable this just in case I forget. For anchor bolts, this is foundation bolts. You can just add something here. Well, you don't have anything here. You have just the standard. By the way, now truth to be said, I wanted this video to be short, but let me give you a piece of trivia. You can see that most of them do have the Polish or Poland norm. You can see Polish norms everywhere. The reason why this is because I think that Autodesk Robot actually was called Robot Millennium back in the day, and I think the company that was producing it or was developing it was called Robobat. I think it was a Polish company. For reinforcing bars, now I don't have reinforced concrete, but still, since we are dealing with Eurocode, I'll just select Eurocode 2. And you can just select this as default and everything is fine. We go on with this, wire fabrics. Now notice, I don't have reinforcing or wire fabrics, but I'm just telling you that you can select your Euro codes if you want here, EC2 or this, and select it as default. Okay, going to design codes, this is where the things start getting interesting. For steel, I want the Euro code. I have it. If you don't have it, you can select on more, and then you can search for your Euro code, or any code you want, Canadian, Euro, so on. You can search for your Euro code, and even with a national annex if you want, and you can select it and basically just take it on this side. I selected this Euro code, basically, and with the national annex, and so on. Now, any Eurocode should be working. The difference between the codes is minor because each country can apply or change some equations based on their national annexes. You see, the Eurocode is basically a skeleton code that works fine on its own, but the countries in Europe can change some of the values and some of the parameters and even equations as a whole to fit their national needs. It's a really cool document. Anyway, so I'll just select here the Eurocode. For the steel connections, I have the Eurocode ready. You can change it if you want. Let me just check. Wait, what? Sorry, I just opened this. When you click here, you can actually select the national annex. That's kind of cool. You can select here and click on more, and you can see that you have the Eurocode only. The reason, once again, you don't have an ASI code here. That's odd, but it's here, so fine. You can also select, I think, the national annex you want. With that being said, let's go on with this. What about RC structures? I don't have reinforced concrete structures, but if I have timber structures, you can select the code that you want here. I don't have an Eurocode here, so I can go to the reinforced concrete, try find my Eurocode, which is Eurocode 2. I'll add that, set as current, and apply. You can see it's here. Geotechnical, well, I want the Eurocode again, Eurocode 7. I click that, set as current, okay, and I think that's that. What else do I have here? I have loads. That's a long video, actually. I want to add my Eurocode, so, sorry, I just click on the preferences. I select more and try to find Eurocode. I think it was Eurocode 1 or something. Let me just check. Yeah, there we go, Eurocode 1. Okay, fine, I'll just choose my British Eurocode. Eurocode 7 is geotechnical, I don't want that. I just select here for Great Britain because our reference is British, so let's select British. For snow and wind load, let's go to Eurocode again. Where is it? There we go. So, okay, close. And for seismic loads, I think it should also be Eurocode 1. Eurocode 8, yes, my bad, because seismic is a special kind of loading. Okay, so I think I have my systems ready. I can just go. And by the way, there is a rest of things here, the structural analysis system. What you might need is meshing, which you can change the mesh size, and there is a full video talking about slabs and meshings. There's a playlist I will link above, and a video that talks about meshes. So I'll save this. No, I will not save this as defaults, my bad. I will not click on Save Current Parameters as Defaults because I want to get back to my American codes in the future. If you click Save Current Parameters as Defaults, then everything I changed here will become your default. If you are a Eurocode designer, then this is where you should click. If you are an ACI code fan like me, then this is not where you should click, and only click OK to have those parameters specific for this file. Now, if I click OK, you see there is something that is being asked from me. Robot sees that member parameters have been defined for code ANSI AISC. That the member parameters is defined for an American code, and it asks you, do you want to convert the parameters to the Eurocode? Because you are asking him to use Eurocode and sees some problems. I've explained this before in materials even. Robot will warn you when it sees materials or parameters of a code that are different than the design code you have. Well, I wanted to convert, so yes, thank you very much. I have it ready, so I'll save my file. All right, so now I just set up my preferences. Now let's go with our structural axis. Please notice that my reference here is going to rely heavily on this, which is basically the typical dimensions. Because I lack an architectural drawing, I have to assume my typical dimensions myself. You should go to the client and ask him what he needs in that warehouse. And ask him, like you go to the plot of land and see how large the plot of land is. It's not just like you can assume anything. But I don't have architectural drawings, so I'm just assuming myself. My portal frame is going to have a span of 30 meters, so 0, 15, and 30, 15 being the apex. NY, I'm going to assume a portal frame spacing of 5 meters. This is according to the recommendation. And I will assume also that it has a depth of 40 meters, so I'm going to repeat 5 8 times to have this. In the Z, I'm going to assume my eaves height to be 8 meters as per the recommendation. Now, I need the eaves height of 8 meters. There is no 8 meters here, so I'll apply that first and deal with it right now. You can see here a story definition of 3 and 0, but my height is actually more than 3. So what is my height gonna be? Well, if you think it's 8, unfortunately, you are incorrect. You are incorrect because the 8 is the eaves height. However, you have to go up to the apex. And to go up to the apex, you would have to pitch your roof by a small degree. Usually 6 degrees is common. Why is 6 degrees common? Because it's easy to calculate. If you take a calculator and just go to 6 degrees, and tan that thing, you will get a slope of 10%. And that's why they like 6 degrees, because it's easy to be implemented. The slope is 10%. Meaning that if I have a height of the eaves of 8 meters and a slope of 0.1, then the total height is going to be, well, this distance, which is 15 meters, multiplied by 0.1, which is 1.5 meters. So the height between the eaves and the apex is 1.5 meters. Plus 8 is 9.5. So the story height here is not going to be 3. No, I'll delete that. The story height is going to be 9.5, and I'll add that. Apply and close. So now I have here my 9.5 meters. That's not enough, because I need 8 meters for my eaves. Now I'm ready, and now I can see my portal frame seems to be all right. I'm a little bit worried about this being too shallow. This will cause larger bending with diagrams. We need to start drawing, right? So I want to draw my first portal frame. Of course, the first question that comes into mind is, what are your sections? Once again, using my reference, and this had a detailed lecture before, the span of frame is 30, so it asks me to tell you if you have a rafter, you should use IPE 400. Also, it tells me that I should use columns. You can see that the restrained column is for 550, and unrestrained column is 550 to 600. So, okay, I'm going to use the rafter for 400 and the column for 550. And of course, this is just preliminary, because we're going to design this anyway. So I select my section here. I'll go to, notice, Eurocode is the first database that is selected. I'll go to my IPE family, IPE, and select the IPE 400 for my rafters. I can rename it if I want, rafter. I'll add that, close. Wait a minute. This is A36 material. That's American standard. It shouldn't be the case. I think I messed up. Strange. I think I selected American, didn't I? I think I selected the American. Wait, this doesn't make any sense. Give me a second. Materials. Yeah, Eurocode material, right? So why is it taking A36? A36 is an American material. Okay, so I quickly went to my reference and checked out the material. Sections are generally S235 or S275. Okay, so, but why did it do this? I mean, oh wait, it's still A36? How? I'm selecting the material database to be Eurocode. So why do I see both Eurocode and ASTM? Good that we checked this, right? Okay, so I'll select 275 as per the recommendation and choose IPE 400. Okay, good that we checked this out. I mean, usually I mess up and the editor starts laughing at me, but today we're doing good, I guess. IPE 400 actually means that the height, I think if I remember correctly, that the height is 400. It's different than the ASTM designation. The ASTM gives you the height and the weight. So I'll add that, close, okay, seems fine. And then I will add my 550. That's really strange. It keeps giving me the ASTM here. This is annoying. I guess because I installed it as American code, it seems now if I add Euro code, it just messes up. Okay, never mind, I'll just deal with it. So I'll select IPE. I'll select my 550 as per the recommendation. I'll add that and close, and now I can start drawing. So the IPE 400 is going to be my rafter. Notice, let me just check, 400, material is correct. Notice, everything we do right now is just a preliminary design. We have to design this in detail in the future. Double click on front to have the front plane, and so I'm at y equals 0 now. Because if you don't double click on front, if you click only on front, then you are in the 3D view. And for example, let me show you. If you select something haphazardly, sometimes it will select something that is just a little bit behind here. So to be sure that you're selecting only what you are supposed to select, double click on front or select here instead of 3D your, I think it's YZ frame, XZ plane. And now you are in the XZ plane at y equals 0, sorry. And if you go to 3D, you get back to 3D view. Okay, so XZ, because I want to draw with a peace of mind. So if you draw, that's horizontal beams. You should not have horizontal beams. So if you draw it now, I will drag that. That's drawing number 1, and that's number 2. So now I have my rafters. Perfect. And now we need to draw our columns. I select column. My column height is 8. My beginning is here. So it should, of course, plant a column down, exactly as it's supposed to be. If you go back here, everything seems to be fine. Now, you know me, I like to dry run this. So, of course, if I'll dry run this right now, it will give me an unstable structure because it's in 3D. Yeah, see, it's unstable. It's in 3D, and it wants to rotate around the x-axis. Basically, if you push it, it will fall down like a house of cards. That's not what I want, so I'm basically going to add me a fixed support here. The fixed support I'm adding here is just because I want to test the theory here. So I add the fixed support just to check if everything is fine. I need to go back to pinned here because my assumption today is that the support here is a pin. So if I go to results, diagrams, members, I select MY and it seems to be fine. Of course, this is fixed, should not be fixed, but I think the analysis at least is working flawlessly. All right, so let's remove this or let's keep it for now. And let's continue. I will have to remove this and change this to pin later. So, okay, everything seems to be fine. Now we need to basically copy this portal frame multiple times. Before I do this, well, there are purlins that connect the cladding to the columns and rafters. And I need to know exactly what the distance between those purlins are. And because those purlins carry the cladding is what dictates the spacing of the purlins. What I mean by this is that the cladding dictates the purlin design or vice versa. If you space your purlins too much apart, you would need thicker claddings because they want to span over the purlins. And if you space your purlins near each other, your cladding becomes less of thickness. So it kind of depends on your cladding suppliers at your location. I will assume my purlin spacing to be at 2 meters, and this is something you need to ask your local cladding supplier. Something I cannot give you the answer for. So I'll select this thing, go to edit, go to divide, and divide this into little pieces. So I want to divide this by a distance. No, I want to divide this into n parts. Now, I said 2 meters, but truth to be said, I will not be able to make 2 meters. For this, I will be, because it's 8 meters. If I divide it into 4 pieces, then I get, well, my 2 meters each. Let's go to Tools, dimension lines and just calculate the dimension. So there we go, it's 2 meters. That's not always the case because take a look at the rafter, for example, here. This rafter cannot be just divided into 2-meter pieces because the length of that rafter is not 8 or 10 or whatever. The length of that rafter is basically Pythagorean. It is, let's take a look, 15.07 is the distance. So I can divide this into maybe 8 pieces. I think 8 should be working. I want to divide it into pieces that are somewhat near the 2. So okay, I'll go to Edit, Divide, and I'll divide it into 8 pieces. Notice I'm generating nodes without breaking the members. And I want to execute this here, so I have it now. And I want to click here, so I have it now. And for the last one, I select this back to 4 and click here, and now I have everything divided. Let's just double check very quickly. First of all, I'll delete this abomination. 1.88. Okay, 12 centimeters difference. When you buy your cladding, you will buy your cladding that is fit for 2-meter purlin spacing. The 1.88 meter are not a big deal. Now, that's not 100% correct. Why is it not 100% correct? I will do something very quickly and discuss why in a moment. So give me a second here. Let me just show you a very quick trick. I made a small trick. I will explain this in a moment. This doesn't work. Why doesn't it work? Because the last cladding here is basically dug into the ground. You need to provide a purlin here. The purlin here is missing. Also, here you have one purlin that seems to be giving 2 claddings. And this doesn't work because your purlin is usually a C channel, so how are you going to fix 2 claddings in one purlin? So I think I need to add a purlin here, and a purlin here, a purlin here, and so on. So okay, let's Control-Z this very quickly. Wait, did I mess up my column? My error senses are tingling. I think I messed up my column, right? Ah, come on, really? Fine. Okay, now I have it. Because I wanted my column to have a different section than my... I can see the editor laughing it out now. Yeah. Keep laughing. All right. So I think I'm ready now. There is something as explained before. I want to basically have an extra purlin here and extra purlin here. And even I can delete this if I want. So I'll just go here to Edit, go to Divide. And this time I want a distance. And this time I want a distance of 20 centimeters maybe. So I want my first purlin to be just 20 centimeters away from the start. So I have a point here, as you can see, and 20 centimeters away from the start here, and 20 centimeters here, 20 centimeters here, and so on. So I added points at 20 centimeters away from the edge. You can see them here. Let me just open the point numbers. You can see a bunch of points here because I want to have purlins here. Okay, and now the magic happens. I select everything. What's the idea? I'm planning to drag my copying. And if I select the support, then I will be dragging a purlin along the support. That's not what I want. But I will make the mistake anyway. So let me select everything and go to Edit, Move or Copy. And I'm going to copy this 8 times this time. I will drag it. What does it mean to drag? It means that you are dragging along the points. So each point becomes a member, a purlin basically. And I'll select this from here to here. This will cause a problem because the active section right now is this. So when you drag, everything you will generate will have this section. So to kind of get rid of this problem, I'm just going to define me a C section. In the next videos, I will be defining a purlin section, yes. But for now, I'll just decide to define me a C or U section here. Any section, just a placeholder. So basically, this video is like tricks and tips of modeling. I select this first of all. Now the active section is UAP80. So if I drag right now, the sections should be a U section. And indeed they are. Perfect. Now I still need to offset that stuff. There is a full video where I have to offset those things. For now, I'm just doing the general structure. Now I messed up. Remember I told you that I don't want to select the lowest point because the lowest point has dragged the purlin here, which I do not need. So I will just delete this very quickly. I'll select here. And a good trick, a cool trick you can here is to select front without double clicking. And now, cancel. And now if you select this, and if I hit delete button, I would remove the purlin. Okay, delete. Let's just try that. Oh, it worked. Great. Okay, I'll just select that and delete. And now, okay, delete please. And now I have my structure. There are 3 purlins here. I know this section I will delete. All right, let me just try to select that. Delete, and I'll select this and delete. Okay, let's take a look. Yeah, this is gorgeous. Oh wait, there is an apex problem. Okay, let's go to here. This is kind of stuff, this is your bread and butter when you model, to be honest. Like, you see me doing all those robot videos. I mean, I could make them work in the first time, but that's not realistic. I wanted to see the real thought process of an engineer in modeling. Okay, so I think now it's gorgeous. Now, if you run the analysis, it's 100% stable because you have frame actions everywhere. That's not what you want at all. Let's select this purlin and go to results, diagrams members. Now, I select MY, open a new window, and OK. And now it should be opening the purlin in a new window, right? Right. And now if you apply, I can't see anything. Really? Okay, normalize. Oh, there we go. Yes, finally. By the way, I'm not making this up. This is how I model an Autodesk robot. Those are the questions I ask myself whenever I model an Autodesk robot. I'm just keeping it real here. So yeah, you can see the purlin is continuous. There is frame action. That's not what you want. So this is utter garbage. I mean, look, the structure looks really cool. I can make a very cool thumbnail, a clickbaity thumbnail. As a matter of fact, I will use this as a thumbnail. But it's utter garbage because we still need to modify that, right? There is a fixed support here. The purlins are continuous in action. So you can impress people with a thumbnail. But this is still utter garbage. And we need yet another video to fix that stuff. But for now, let me try to fix whatever I can fix so far. I didn't provide any bracing so far. I have not provided anything. Remember, this is a multi-parter. And I don't want the video to be like hours long. We want our purlins to be released. Now, are the purlins released? The answer is yes. Because remember when we have showed you the connection detailings of the purlins, this connection detail is the purlin to beam connection detail. So you can see the purlin is basically a simply supported purlin. It still transfers, in my opinion, in my humble opinion, this type of connection still transfers axial force and shear, but it doesn't transfer moment. So I'll just select it to be released in both ends. So okay, selecting our purlins and releasing everything. Now you would have to select them one by one, right? This would be a nightmare. No. The reason why I was using different sections is exactly this. If you double click here, if you click on your selection tool and double click on the section, you select all the members of that section. It's kind of cool. Now I go to geometry, releases, and of course, this is where our instabilities will start popping up. So I will have pinned. I'll apply that. So everything is now released. Let's run the analysis now. See? And now we are back to the instability festival because we have released our stuff. So now our structure is unstable. But this is something that I will have a specific video for that because stabilization is a bloody nightmare. However, just to show you, if you click on a node and select diagrams members and select MY and open a new window, you can see that it should be a simply supported moment action, and that's exactly the case. It's a simply supported moment action, I guess. Don't mind those lines. This is just because of the parameters here, because you're using this line hatch. You can just select filled, and you know those cool things, and now you have a filling, so it's not a big deal. Notice that I didn't apply any loads. Okay, so I think that some of you might be boring because they would even call me out because now I know that this is most part something I've covered before, but it's the first step. I have to do that, right? Like there is no way I can just show you the hanger and tell you, hey, let's continue from here. So what have we done so far? What we have done so far is that we have prepared our job preferences, we have drawn our portal frame, we have talked a little bit about some aspects of drawing the portal frame, and now we have basically prepared a skeleton structure. Now there is a lot more to be done here. At least you need to stabilize the structure. Our plan now for the next video is going to be stabilizing our structure, doing some offsets, because yes, purlins are offset, to be honest. They are connected to the upper flange, and I will offset them. And so I have to offset the purlins, I have to stabilize the structure, I have to apply claddings, and I have to apply loads. So this is the topic of next video. So this basically ends my video for today. Of course, before I finish, I want to give a whopping shout out to our dear channel members whose names are going to be shown on the screen. Thank you very much for considering the membership of the channel. You are supporting the channel a lot, and for that, I'm very thankful. With that being said, I hope that you enjoyed the video and that it was beneficial for you. Of course, if you have enjoyed the video, then please like, share, comment, and subscribe, especially subscribing because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video.